All right, let's talk about converting the NFA to DFA. Last time I made the class, but it unfortunately did not record, so let me do that again. Now, I have an NFA here where Q0 receives an A, goes to Q1. Note that Q0 does not have a B output. There is no B output. If this was a DFA, then I would have a B here, but in an NFA this is not required, so I don't have a B here, so I will remove this again because it's still an NFA. Now from Q1 I have one output that's on. If I have an A, then there is a loop from Q1 stays in Q1, but also I do have a lambda transition which makes it NFA. Now from Q2 I have a B. This is my B here. Let me mark it with red. Okay, so this is my B connection. But on A I don't have an A. I don't have an A transition from Q2. So this is my NFA. Now I want to convert this to DFA. The way I will do that, I will start with Q0. That's my initial state in the NFA. I will have the same initial state in my DFA. This is my starting point. And I will prove the ability to convert NFA to DFA by procedure, which means I will show the procedure here. And this procedure will tell me that I was able to convert the NFA to DFA. Now, so I do have a Q0. Now let me go to the next slide. Next slide, I say, look, if I have a Q0 here on my NFA and I have an A input here, A transition, where does this A take me? Number one, this A takes me to Q1. There's Q0 to Q1 on A. Also, on A, once I am at Q1, I still have a lambda. So the lambda here, it means if I have an A, I go to Q1. But if I have an A lambda, like this here, let's have an A lambda here. Okay. So I have an A lambda, which is mean A followed by a lambda, then it takes me to Q2. So if I receive an A is equivalent to A or to lambda A or to A lambda, then I go to Q1 and Q2. What I will do, I will create a new state. I will call the new state Q1, Q2. This is a new state. This can be, actually I can call it almost anything I want. I can call this state P. I could call it P1. Okay, but P1 consists of two states in the NFA, Q1 and the Q2. Now I don't really need the P1, so I will take it out. So this is my situation. If I have a Q0 on my NFA and I receive an A, I will say, look, go to a new state, Q1, Q2, which is one and only one state, Q1, Q2. So I don't have this lambda anymore. Okay, now I will go. Now note, as I said, Q0 in the NFA should have an B input, should have a B transition, but in the NFA I don't have the B transition. For DFA I must have the B transition. So here I go down here to my DFA construction. I say, what if I get a B? Well, if I get a B, I will go to a state, I will call it the trap state. So I create a trap state, I call it phi. So now from Q0 I started absolutely deterministic. If I get an A, I go to a state Q1, Q2. If I get a B, I go to phi, trap state. So this is this link here. I say I'm creating a B transition, although I did not have the B transition here. So that's what I say here, delta on Q0 comma B equal phi, or the empty state, which is my trap state. So that's Q0 comma B in the here in the NFA, it's undetermined. So I create a new state, so I will make it deterministic. It was and deterministic. Now it is deterministic. Now I go to Q1, Q2. So I'm done. Q1 for sure. Q1, I'm done with this. Let me put it green, which means I'm done with it, because it has two transitions. Now I will start with the Q1, Q2. Q1, Q2, I have two alphabets, A and B. Let me see what happens if I get an A. If I get an A, the way I will do it, I will say, what if I was in Q1 and I get an A? What if I was in Q2 and I get an A? Then I combine both, the transitions of A for states Q1 and Q2. So let's see Q1. If I get A and I'm in Q1, I stay in Q1. But if I get A lambda, because A is followed by lambda is as good as A. So if I get an A, I stay in Q1. If I get an A followed by a lambda, which is the same as A, I go to Q2. So my transition, if I am in Q1 and I receive an A, I go to Q1, Q2. And if I am in Q2 and I get an A, I don't have an A transition here. I have a B transition. All I have is a B transition. I don't have A. So the A transition from Q2 will be, I will just say it will go to something like this. It will go to a phi state. If I had an A transition, let me put it this way. If I had an A on Q2, then it will go to a phi. But I don't have an A. So now, if I am doing the DFA, here I will say Q2 comma A equal phi. Now what I will do, I will combine Q1, this transition, Q1 comma A and Q2 comma A, I will combine it with a union. So I will say this union this equal Q1 Q2, because phi union anything else stays anything else. Which means this state Q1 Q2, if I get an A now, I'll mark this red and make it bold, which means this is my transition. So Q1, Q2 and input A is well defined. Let me see what if I get a B now. So now I have this A, I've done this one more time. So let me see, what if I get a B? Again, if I am Q1 and I get a B, note that I don't have a B transition over Q1. However, I have this lambda, followed by a B, which is this one, so this is my lambda B. So Q1 lambda B. So if I am in Q1 and I receive a B, it will take me first to Q2 and then to Q0. So that's why I have here Q1 on input B is Q0, and Q2 here, if I am in Q2, if I am in Q2 and I get a B, so I go back to Q0 as well. So now Q0 union Q0 is a Q0. So I will say, now I have a Q1, Q2. If I get an input B, the input B will take me to Q0. Bingo. So I created a new state. I called it Q1, Q2, which I was calling it P1 in a few minutes ago. If I have input A, I will stay in here. I will stay in Q1, Q2. If I have input B, I go back to Q0. Q0, if I have input A, I go to Q1, Q2. If I have input B, I go to phi. Now, what if I get I think I'm done. Oh, the only thing remaining. Okay, I am on the trap state. What if I get A or B? Of course, I will stay in the trap state. It is a trap state. So this is here. It's my trap state. So note that now this automata down here, Q0, Q1, Q2, phi, it is a deterministic. Because Q0 has two transitions, A and B, no lambda. Q1, Q2 has two transitions, A and B, no repetition. This trap state or the 5 state has transition A and B, so it is absolutely deterministic. So now I was able to convert the NFA to DFA, and now one thing remaining, what is my final state, accepting state? This is what I will do. I will check, I have Q1 is final. I will look, where do I see Q1 here? I see it here in this state, so it's part of the state. So I will make all of the state final. So whatever is accepted here is accepted. So Q1, Q2 belongs to my final accepting state. And Q0 continues to be my initial state. And this is definitely is my DFA. Now what does this DFA accept? Or what does the NFA accept? NFA, this one will accept, this automata here, this big one, this automata, let me take this out from here, out, and let me group it. So I will make it as one. Oops, it doesn't group. Anyway, okay, I think I can do it this way. Okay, that's fine. Let's keep it this way. So this automata accepts the same language as this automata because they are the same. So let me see, let me take this out again and fill it. Let me say I begin with an A, it must begin with an A. So if I begin my automata with an A, it will take me from Q0 to Q1. And if I stop right here, only A, then the string is accepted. From here, it's accepted at this state. So it's accepted here. All right, with one A. Now, what if I have AA? If I have an AA, it will also be accepted. I have one A here, then I make this loop here, and I am accepted. What if I get one more A? I'm still accepted because I keep in this final state. Now, what if I get after that a B? The B now takes me from Q1 on lambda, and with a B, it will take me back to Q0. And if my string stops at AAB, then it's rejected. I'll reject this. Now let's see if I go down here. With an A from Q0, I take this A. If I stop right here like the first string, this string number 1, and this is string number 2. On string number 1, if I have one A, I get here and I am accepted as up, which is exactly the same. If I get A followed by an A, followed one more time by another A, one more A, let's put it this way, one A, second A, third A, so I have 3 A's, I'm still accepted. But now if I get a B, like here, Now I have 3 A's and a B. I end up at Q0 and it's not accepted. So let's get one more. 3. Let me get A, B, A, B, A, B, A, B, and A. Okay? And let me do it here. First A, this is my first A. Second A, third A, lambda B. I get here, then I get an A, then I get an A, then a lambda B, back to Q0, then an A, then a B, which is lambda B, I get back to Q0, then one more AB, one more round, then A, one more lambda B, and then finally I get an A here, and I am done. Accepted. So this is accepted. Except on the NFA. What if I have it on the DFA? Same. First A, second A, second A, third A, this third A, then a B, then an A, one more A, then a B, then an A, then a B, then an A, a B, then A, then B, then finally it's an A, and I am accepted. So these two automata, the NFA and DFA, accept the same language. What is this language? Here. That's the language. L equals, it's equal A, followed by a W. The W now is any string, which consists of A, B star, any combinations of A, B, 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 A, whatever. However, it must end with an A. It has to end with an A. If it doesn't end with an A, so now this is here. I have an A. Now, from here, from Q1 to Q2, you keep moving between A, B, and then now, of course, I think there is one caveat here. It's not any, because I don't have BB here. If I have a BB here, this is not quite true. L equals A omega A. Now what I will do, my friends, I will say make correction to this L. You have to make correction to explain what language is accepted. Now AWA is not accepted by the string. Because why? I will show you why, but you have to tell me what is the correct language. So if I have a string like this, if I have string 4, I will say it, and let me reduce the size here so I can have more space. Here, if I have A followed by A, B, this is okay, but if I have now one more B and then A, this will not be accepted. Why? This is also rejected. Why? Because when I have the first two A's, this A, first A, second A, first B, I come here. Then after this B, I have an A, I come here. Then after this A, I get a B, I go here. Now I have a second B. The second B, after the B, it will go to the trap state. And I am trapped. This will not be accepted. So this will accept all the strings A WA such that the W does not have any successive B's. Okay, so but you have to formulate this language. Okay, I'll stop the recording right here and go to official procedure for the